right, we are in our science lab this morning. Morning Show Kitchen, whatever you want to call it, with Jesse Miller this morning for our Chemist's Corner. Jesse, good morning.
Good morning.
We're doing some fun stuff today.
We are indeed. So we're going to talk about hydrogen right now, with hydrogen being looked at as an alternate fuel source for hydrogen fuel cells and things like that. You got to wonder how much energy is in hydrogen. I mean, we've all seen pictures of the Hindenburg video of it exploding. And the reason why we don't use hydrogen in dirigibles anymore is because of the Hindenburg. They now use helium, but helium's starting to become a little bit more expensive. So I'm not sure how much that's going to go on. But what I have here is not a helium balloon. This is a hydrogen balloon.
Okay.
And just for fun, here we can have Cynthia hold it away from your hair because you're probably wearing product.
This body's all natural. Yeah, right.
And if Drew, if you want to.
Oh, gladly.
If you want to do
my
that.
arms aren't long enough to like hold it.
Do you want me to hold it?
No, I'll try.
Okay.
I'll be brave.
All right, there we go. Go ahead. It's not going to be loud, but you will feel. Go ahead.
No!
Yeah.
All right, so as you can see, thank you. As you can see, there's quite a bit of energy.
Feel that heat.
When hydrogen and oxygen combine, okay, it goes to a lower energy state and it gives off its excess energy, and we see that as sound and heat and light. Okay, so what we want to do is we want to harness that in a hydrogen fuel cell in order to, instead of wasting it with light and sound and heat, we want to make that into some sort of useful energy. So that's, and I'll bring in something for hydrogen fuel cells at a later date. But it begs the question: where are we going to get this hydrogen from? Okay, hydrogen is too light to stay on the Earth. Okay, the gravity's not strong enough, so it goes away. So we have to get it from other places. Now, there's a lot of hydrogen. I mean, water has a lot of hydrogen in it. Your body has. I mean, everything has hydrogen attached to it. So we have a big source of water in the world. That's the easiest way to get it. And this is actually how we used to do it on the submarine to get oxygen. We're going to split water into hydrogen and oxygen using electricity.
Okay.
Okay. So what we have here is we have a couple of electrodes, these little pieces of platinum in here. And on one side, you have hydrogen being, well, water being, the hydrogen being, let's see, it would be being reduced, okay, and producing hydrogen gas. On the other side, we have oxygen being oxidized and producing, or it's the opposite. I'd have to think about it for a second. Anyway, it's not that germane. The point is that on this side, the hydrogen is combining, we're stripping the water of its hydrogen, it's combining together and forming hydrogen gas. On this side, we're taking oxygen out of the water and it's forming oxygen gas. And you can see, I can tell which side is hydrogen and oxygen because this side is twice as much gas as this side. Okay. Hydrogen, there's twice as many molecules of hydrogen in water as there is oxygen. So as this would go on, and I've only been doing this for about 15 minutes, as this would go on, you would see that change a lot bigger. But you can see it here, that it's about twice as much hydrogen as it is oxygen. And we can do this, and it really doesn't take that long. Like I said, I've only been doing this for 15 minutes, and this is a very small apparatus. And as I said, on the submarine, this is how we got oxygen to replenish, because once we went down, we didn't come back up, so we had to make our own oxygen. And this is what we used to call these the bombs, for obvious reasons. So anyway, so this is one way we can get hydrogen.
Okay.
The problem is, if you took all of the hydrogen production in the world today, okay, in all year, it wouldn't equal the amount of energy production from gasoline in a day.
Oh, yeah.
So in order to make that shift, we're going to need to figure out how to produce a lot of hydrogen. And you don't get something for nothing. We're putting electricity into here.
Right.
So then that means we need to have a source of electricity in order to split the hydrogen. There's other ways of looking at it. They got methane rectifiers. But the problem with that is, see, hydrogen is very clean. You mix hydrogen and oxygen, you get water. You mix methane, you're going to get hydrocarbon products, which we don't like, right? And we're trying to get away from with the fossil fuels. So it's cleaner, but it's not as clean as just hydrogen. So in order to make hydrogen fuel cell cars practical, we're going to first need to figure out the fuel supply problem and how to get that energy from that way.
Okay.
All right. Do you want to do another balloon?
Might as well, yeah.
I
So I
brought
can
you.
hold this
You're
one.
going to need to color
I
that
get-
eyebrow in a little bit when we take a
I think I have
Do you
like
wanna
a
switch?
little heart
You wanna
attack
hold it?
every time
Yeah, I'll
that-
take one for the team here.
All right, but don't get it too close to your hair.
Oh, sure, yeah. Not that I have any product in my hair. This body's all natural. Isn't that what you said?
Talking about my hair.
All right, so
wait.
the flame is going to get the reaction started. Once the reaction starts, then it pretty much
That light is
goes
gone.
on its own. There we go.
Oh, that was not a good idea to do it that close to.
Yeah,
Still burning.
we
the
did.
light.
Back in the
In
days
here.
before they remodeled this studio, every time I do this, stuff would just rain out of the, the ceiling.
We've
But
just fixed our camera so they don't show that anymore.
anyway, so as you can see, there's a lot of energy.
Big
in here.
reaction.
What's that?
That's a big reaction.
It is. And if I would have added oxygen to it, see, it's just now scavenging the oxygen out of the air. So the reaction is slow. That's a slow reaction. If I was to add oxygen
Oh.
to it, which then it would make a very large, noisy reaction, very fast. And
Unlike the one that we just had.
yeah, that was slow. So this is my job. This is what I get to do. It's fun. So like in our Christmas shows that we do, we usually do hydrogen and oxygen together, and we've been known to knock computers out and things like that.
Nothing says the holidays like enormous explosions, right?
That's in my world. Anyway, that's the fun. So anyway, so this is hydrogen. This is how you can get hydrogen from water. It's called electrolysis. I don't know if I mentioned that before. Not electrolysis like removing hair. This is electrolysis in the case of splitting, using electricity to split water into hydrogen and oxygen.
All right, Jesse, as always, thank you.
We'll be right back.